Hi there, and welcome to today's class. This class will look at the concept of inverse trig function of differentiation. We have done a full tutorial video on differentiation from scratch in calculus. So if you're interested in watching this full tutorial video of differentiation from start, I'll leave a link in this video description. You see a link that will take you to our very first class on differentiation, really from the beginning to where we are now. So check the video description. You'll see a link there that will take you to our very first class on differentiation. All right, let's move on where we stop. So the next thing want to look at now is called the inverse trigonometric function of differentiation. When we say inverse, by inverse we mean something to the power of minus 1, right? Basically. So when we look at inverse trig function of differentiation, the trig function here we are considering are just three: sine, cos, and tan. So I'm saying this, please, under this concept, given that y is equal to sine inverse of x, from this concept we said the y dx here, the y dx is equal to 1 all over root 1 minus x squared. So if you are given that y to be equal to sine inverse of x, if you differentiate sine inverse of x, you have that the y dx is what? 1 all over root 1 minus x squared. Also, that's for your number 1. Number 2 is that given that y is equal to cos inverse of x, obviously the y dx here, the y dx is equal to negative 1 all over root 1 minus x squared. Now here's the task, please. Observe the similarity between 1 and 2. For 1 and 2, the answers are the same thing. 1 root 1 minus x squared, similarly thing here. The difference is it for inverse cos, the answer just attach negative to it. So if you can know sine inverse of x, it means you can know the answer for cos inverse. The only difference here is the attachment of what? The negative sign here. So negative sign here, here has no negative sign. This is second inverse trig function you need to know. Number 3 there is given as let's say given that y is equal to tan inverse of x. It means that the y dx is equal to 1 all over 1 plus x squared. This is your derivative for tan inverse of x. Please, these are what you need to know in the study of inverse trig function of differentiation. Before I move on and proceed further, I would like to prove I would like to prove each of them one after the other. So let's prove each of this concept. Why is it that if I differentiate sine inverse of x, I will have this answer? Why? Also, why is it that if I differentiate this one here, I will have this? And why if I differentiate tan inverse of x, I will have this? Let's prove this concept one after the other. Before we prove, there are some trig functions you need to know. Trig identity, that is, let me just write them here. Please note that if I have sine squared y plus cos squared y, this is equal to 1. These are called the trig identity. Also note that 1 plus tan squared y is equal to sec squared y. What we know generally from trigonometry is that you have sine squared theta plus cos squared theta equal to 1. Also 1 plus tan squared theta equal to what there? Sec squared theta. These are what we're familiar with. So here's the thing here. I can either change this theta to be anything. So in this case here, I'm choosing to go with y. no problem. The task is this: they must be together, they must be the same thing. So if I have sine squared theta plus cos theta, see this theta and theta must be the same thing. Theta and theta must be the same thing. It means y and y must be the same. Y and y must be the same. If this is true, if you observe closely, let's try to make sine squared y subject. By the way, my goal is to make sine y subject and also make cos y subject too. So if I pick out sine squared y plus cos squared y equals 1. If I try to make sine y subject, it means I'll take this cos squared y other side. That gives you sine squared y equal to 1 minus cos squared y. Here's the thing here, I'll take this square to the other side, gives you a square root. That gives you that sine y is equal to the square root of 1 minus cos squared y. Now I have made sine y subject. I need this one. Let's now make also cos x, cos y subject. To make cos y subject is simple as just replace it this way. Alright, at saying this is sine y, that gives you a cos y equal to the square root of 1 minus, here is cos y, that gives you a sine squared y. Follow the pattern of this one to get this one. So anywhere I see sine y, put cos y, put sine y. So I need these two concepts in dealing with the proving of this. So I need these two. I need 1 and I need these 2, right? Also, I also need number 3. If you check this 1 plus tan theta, so I want to try to make tan y subject. If I make tan y, so it means that tan y, I'll have that tan squared y equals, this gives you sec squared y minus 1. Take the square root, it means that tan y will give you the square root of, hold on, before I do tan y, let's prove 1 and 2 first. Let's hold on with tan y for now. Let's hold on with tan y. Alright, so it means I need these two expressions in proving this 1 and 2. When we get to this one here, I'll give you what to use. So let's look prove it, please. So given that y is equal to sine inverse of x, we said that dy dx is 1 over root 1 minus x squared. Why is it so? Here is it, please. I'm going to start here. This is equal to y equal to, this means 1 over sine into x. If I have a to the power of minus 1, it means 1 over a, right? Indices. Similarly, sine inverse means 1 over sine, then x. So next start is 1 times s gives you x. So I'll have that y is equal to 1 times s gives you x all over, I have sine here. This means I'll now cross multiply. Y times sine gives you not y sine but sine y. Make more sense. So y times sine gives you sine y equal to x times invisible 1, it gives you x, right? I'm having this, please. Alright, I'm having this. Now I'll differentiate this one here using the idea of implicit differentiation. Right? If I differentiate sine y, I'll have cos y. In bracket, attach dy dx. If you are familiar with implicit differentiation, we said for implicit, anytime you differentiate y terms, you must attach dy dx to it. So it means if I differentiate sine y, that gives you cos y. Attach dy dx to it. It's equal to, differentiate x, that gives you 1. My next task now is that I want to make the y dx subject. That's what I'm looking for. So I want to make the y dx subject. I have to divide here by cos y, divide here by cos y. It means this will cancel this. So I'm saying that the y dx now, the y dx now will be equal to, alright, so we're saying the y dx now will be equal to 1 all over cos y. Now watch please. Cos y. What's cos y? We said cos y is what there? Root 1 minus sine squared y. This is how I got to this expression you're seeing here. This is how I prove for this number 1 concept. Let's prove for number 2 and see what we get. Okay, take this off. Become cos given that y equals cos inverse of x. Alright, so let's try to prove that the y dx is negative 1 all over root 1 minus x squared. We know that this y gives you y equals, this cos inverse means 1 over cos into x. Multiply y by x, that gives you that y is equal to 1 times x gives you x all over what there? Cos. Multiply, our what? Cross multiply. Cross multiply. That gives you y times cos, or perhaps cos times y gives you cos y equal to an invisible one here. So 1 times x gives you x. At this junction here, I will differentiate this one using the idea of implicit. But when it's cos y, that gives you minus sine y. Of course, attach the y dx to it because we're dealing with the idea of implicit differentiation. That is equal to the difference x, that gives you just 1. At this junction here, I'll try to make the y dx subject here. So I have to make divide both side by what? Negative sine y over negative sine y. That is, this will cancel this. I'm left with what? I'm left with dy dx to be equal to, of course, in mathematics, you are not expected at this level in mathematics. You should know that it's not possible or is not making sense, or perhaps say it's not allowed in mathematics for you to put negative sign at the denominator section. So negative sign should not be in the denominator. What do you do in that case? You shift it up. So I'll bring it to this one. That gives you minus 1 all over what there? Sine y. But don't forget that I showed you something that sine y is what there? This expression. So it means that the y dx now, the y dx will be equal to negative 1 from this one here all over sine y. What's sine y? That gives you the square root of 1 minus cos squared y. This is how we prove for this second expression here. This one and this. This is how we prove for this second expression under the concept of inverse strict function of differentiation. Let's do the last one and see how we got to 1 all over 1 plus x squared. So I want to ask, why is that having plus here? Why is it not having root? Let's see how we got to this concept. Right, take this off. Alright, given that y is equal to tan inverse of x, apply the same procedure. Math is not really that hard. If you can understand the foundation, apply what you have learned in the foundation to higher concepts, right? In this case here, what do? We said you put your y here to be equal to tan inverse means 1 over tan into what there? Into x. We now said you multiply this one by x. It means I'll have this y. Y will be equal to 1 times x gives you x over tan. At this junction, we said what? Cross multiply. So I'll cross multiply. That gives you y times this gives you tan y to be equal to x times 1 gives you x. By the way, I have an invisible one here. You should know that for now. But if it is tan y, that gives you sec squared y attach the y dx to this man, as we said before now, to be equal to the x, that gives you just 1. At this junction here, I will try as much as possible to make the y dx subject. So divided by what? Sec squared y, hereby sec squared y. It means this man here will cancel this man here. I'm having the y dx left to be equal to 1 all over what there? Sec squared y. By the way, let's go back to this place. Right, so if you can see very well, I can see sec squared y. So I'll anyway I see sec squared y, it means I can replace it to be 1 plus tan squared y. So it means I'm seeing sec squared y here. I can put it as what? 1 plus tan squared y. And don't forget please that the y dx will be equal to 1 all over this 1 plus, we just said tan y alone. Tan y alone is x. But having square here, it means I'll have x squared as my final answer. This is how you differentiate or you prove this concept of inverse trigonometry functions of differentiation. Let's take some few examples under this concept and see how we can solve examples under the idea of inverse trig function of differentiation. Alright, so let's take some example in the study of inverse trig function of differentiation. Example, it says find the y dx in the following. Alright, so let's get this done. For number 1, I have that y is equal to tan inverse of exponential x. Number 2, I have that y equals cos inverse of ln x. Number 3, y equals sine inverse of 2x all over 4x plus 3. I have this. Number 4, I have that y equals tan inverse of exponential 2x over s squared plus 3. Alright. So we are having these 4 questions. I will do one for you. We'll look at 2, 3, and 4 in our next video. So make sure you watch the next class after this one to better understand how we solve 2, 3, and 4. I'll leave the link to the next class in this video description. So check the description. You'll see the link to the next class on this 2 and 3 and 4 video. So let's start number 1. For number 1 there, I'm having that y is equal to tan inverse of exponential x. When you are asked to solve any problem under inverse function, by the way, I don't have to tell you that this is inverse function. You can see the pattern to which is coming. So it comes tan inverse. So seeing tan inverse tells you this stuff here is under what the inverse trig function of differentiation. So I don't have to start telling you this is inverse function. By seeing, you should know. By seeing these questions here, see the pattern. This are under what the inverse function of differentiation. That's all. I don't have to tell you, right? So what do you do in this case now? Your first priority, please. Your first task is to call the term in brackets. Any term in brackets, call that term in brackets, call it u. It means that let u to be equal to exponential x. For those that have watched my class from the beginning, I've explained the idea of exponential function of differentiation. In fact, I even show people shortcuts in that video. How you can differentiate exponential function using shortcuts, right? I'll leave the link to all these classes in this description so that you can make some revision for yourself, right? If I differentiate exponential x, so I'm having u and x. This gives you du dx to be equal to, if I differentiate exponential x, obviously I'll have exponential x. I have showed you why. Don't ask me why here. do what to watch our previous classes. I've explained why is if I differentiate exponential x, I'll still have exponential x. I've showed you why. Even I gave you proof to it. Right? So check the video description for revision's sake, please. Next task here, after calling u to be term in brackets and differentiating, your next step now is to repeat your question. What I have here, but from the question we know that y is equal to tan inverse of what? I can say exponential x. I'll write it here because we just said exponential x to be what? To be u. So in other words, I'll just put u here. Why? Because exponential x has been replaced with what there? With u. So I have u here. Now, if I differentiate y with u, that gives you the y over the u is equal to, if I differentiate tan inverse of x, I will have 1. Okay. If I differentiate tan inverse, if I have that y equals tan inverse of x, don't forget I said the y dx in this case gives you 1 all over 1 plus what there? X squared. Now, here was x. Now, here is now u. So, what my answer? That will give me 1 all over 1 plus, instead of writing x now, that gives you what there? A u squared. That's the place. The same stuff, but what? Different variable used. Here was x, here was u. Now, my next task here is to use chain rule. So, using chain rule, all right. I said in our previous class that trig function, log function, exponential function, inverse trig function, you are using chain rule to get your answers. So I'm here now using chain rule. For chain rule, what do we know? We said that the y dx equal to the y over the u times the u over the x. The y dx gives you the y dx gives you the y du. The y du is what? 1 all over 1 plus u squared times, I have the u dx is exponential x. That gives you exponential x. It means that my final answer should be 1 times exponential x gives you, okay, there is off. Okay, let me just try to manage here. Okay. All right. So what is this? So from here, the y dx, observe please, this gives you the y dx is equal to 1 times exponential x gives you exponential x all over what there? 1 plus u squared. I can't leave this man as my answer because I'm having the y dx. It means everything here must be in terms of x. So this u has its own value. That is what there? Exponential x. So I'll replace u what there? Exponential x. My final answer becomes the y dx will be equal to what the exponential x all over 1 plus u is exponential x. By the way, I have a square there. You now take a square of that stuff here. So this becomes your answer to this particular question. Okay. Alright, so we'll look at yet number 2, 3, and 4 example in our next tutorial video. So do watch our next class to better understand how we solve this, and then progression 4 in our next video.